What's up, everybody? Welcome back to week 6 of our quarantine chemistry. This week, we're going to just do a single video because there's not a ton of information to cover. We're going to begin our new section on liquid mixtures. So we're going to move away from gases and move on to liquids and liquid mixtures. Week 6 is going to be an intro. You'll have 2 assignments. One's going to be a inquiry lab scavenger hunt type of deal where you take the terminology, we explore, go out in your environment around you, neighborhood, park, wherever you're at. If you're traveling, you can still do this. Find 3 samples, use the tests we're going to talk about, and classify them. The other assignment for the week is just going to be your assessment at the end of the week. We should have about 2 more weeks of new instruction after this one, and then we'll be doing some wrap-up activities just to finish out the year. So let's get started. So what I want you to be able to do this week is explain how liquids are similar and different from gases. You should define and differentiate between the 4 key terms, which are liquid, solution, colloid, and suspension. Identify the type of liquid mixture a sample is, and justify your classification of it using the Tyndall effect and settling out. Those are the 2 tests we're going to go over. And then you should be able to identify examples of each from your immediate surroundings and environment. That's what you'll do on the inquiry lab. So the week is pretty open, to be honest with you. Monday, you should be watching this video, going over the study guide, defining your key terms. One piece of advice is you're going through your key terms this week and you're defining them. Make sure they are working definitions. Make sure they're descriptions of each of the 4 possible liquid types: a pure liquid, solution, colloid, and suspension. Make sure the description is usable, that if you went out to a park, Peters Lake Park, you went down to Canonsburg Dam, you're walking around your house, your yard, you're looking for liquid mixtures, that you would be able to classify what you're seeing as a pure liquid, solution, colloid, or suspension based on the definition you come up with. So I guess maybe more than a definition, it should be a clear explanation of what it is. Tuesday, Wednesday, and Thursday, you're going to be given time just to work through the scavenger hunt inquiry lab. That should be turned in by 11:59 p.m. Thursday. So I want you to try to get the lab done before Friday. That way, Friday, all you're doing is the assessment, which should be short this week. If you need over the weekend to get the assessment done, you can turn it in until 5/25. That's Monday, May 25th. But other than that, I would try to get all that done before you wrap the week up on Friday, just so that you're not lingering, having anything hanging over your head over the weekend, forgetting to turn things in like some of y'all did last week. So liquids. Liquids, if we define them, are a nearly incompressible fluid that takes the shape of its container but retains its volume. A couple key ideas here. First thing, what's it mean about being incompressible? We've studied gases and we saw that there was a ton of empty space in between the gases. If you think back to the simulations, really, really small particles, tons of space in between them. So we could push them closer together. They were compressible. Liquids don't have that extra space in between. They're actually all touching each other, but they're still fluid. They can move and slide by each other. It's kind of like being in a crowd, a really crowded space, which really doesn't happen anymore because we're all quarantined and social distancing and all that good stuff. But think about life before COVID-19 and when you would have to kind of work your way through a crowd. That's fluidity. The neat thing about liquids is that they're fluid and they're all still touching, They're incompressible. They have a set volume, but they take the shape of their container. So that's a pure liquid. Um, they're super rare. Distilled water is probably the only pure liquid you've ever come across. Mercury and bromine are liquid elements. Gallium's really close. You can actually melt gallium in your hand or over low heat, and it'll liquefy. There's actually a crash course video on liquids where he puts some gallium inside a little plastic bag and puts it in his mouth and it melts. So that's super rare though. Most of the pure substances we come across are either solids or gases. Very few of them are liquids. And in our environment where everything's all mixed together, it's super rare to come across a pure liquid. So what are all these things that we typically call liquids then? Most of them are mixtures. They are things dissolved in water or other solutions or other liquids. But most of the time, it's ionic compounds, covalent compounds, gases, environmental particles like dust or pollution that are trapped inside water. These liquid mixtures are going to be either solutions, colloids, or suspensions. So that's your goal this week, is to go out and about, go through your house, kitchen, backyard, go out into the park, see if you can find liquids and figure out which kind of liquid mixture is it really. Some information that helps us figure out which category, solution, colloid, or suspension, your liquid mixture fits into would be this. Solutions are the only ones that are homogeneous. In other words, you cannot tell anything is dissolved in the liquid. There might be colors or things like that, but you can't see particles floating around in the liquid. They're really, really small pieces. They don't separate. You can't filter them. They're so small that if you shine a light or a laser through them, the light or the laser goes straight through and you can't even see the light or the laser. Colloids, on the other hand, are in the middle. First of all, they're heterogeneous. So you can tell there's something in there. You can typically see some evidence of particles floating around in the liquid. They don't separate on standing though. So they stay mixed constantly. They're never going to fall to the bottom and separate. Typically, we can't filter them, but they show something really unique called the Tyndall effect, which we'll talk about in a second. So if you observe the Tyndall effect, the scattering of light as it's passing through a liquid mixture, then you know it's a colloid. Suspensions are also heterogeneous. These ones you can definitely see the particles. It's almost like dirty water. You can see large particles floating around and moving around inside the liquid. The particles will settle out. So if something's stirred up and you take a glass of it and you set it down and you walk away, when you come back, you'll see a film of particles that have fallen to the bottom. That's, quote, settling out. That's one of our tests. They can be separated by filtration. They don't display the Tyndall effect as much as they scatter and absorb the light. So they're more translucent or murky than they are clear. So you can think about going to like a local stream. There's one in Cecil Park that we go to with our family all the time. On a normal day, the water runs really slow and smooth through there, or like Mingo Creek. water runs really smooth. You can see through the water, you can see the little fish swimming around. But after a huge rainstorm, when all the runoff comes flying off the hillsides with the dirt and the mud and all the pollution, and it runs into the stream, all of a sudden it starts to look like chocolate milk. So those are the kinds of things we're talking about. When things get stirred up, that's a suspension. When it's left alone, they end up settling out in the end, and then you don't have anything left. Now you have a liquid with the stuff that was in it fell out to the bottom. So solutions, homogeneous, they don't settle, they don't scatter light. Colloids, we see the Tyndall effect. Suspensions, we see settling out. So here's the Tyndall effect. If you look at the leftmost cube, this laser is going through this container, but you can't see the laser in the mixture. This is a solution. Here, notice the path. You can see where the laser is going through the liquid mixture. That visible pathway is evidence of the Tyndall effect. The particles are small enough that they are able to stay suspended, but they are scattering the light enough that you can see the path of the beam through the colloid. So this would be a solution. This one would be a colloid because you can see the beam. You don't need a laser. You can actually use a flashlight, like a mag light or a tactical flashlight. So if one of your parents has a flash like that, or you have one, you could see if a narrow beam goes through your mixture, and you could identify if it's a colloid that way. Settling out. Think of a snow globe. You have all these particles on the left that are shaken up, agitated from being mixed, and they're swirling around. If you set it down, you walk away, you're going to end up with something on the right. You're going to have the liquid on top, and then all the particles that were in the snow globe, where are they now? They're at the bottom. They've fallen out. They've settled. That's an example of a suspension. Solutions don't settle or show the Tyndall effect. Think Kool-Aid, Gatorade, things like that. Tap water that has minerals and different chemicals in it to make it safe to drink. Solutions don't settle. They don't show the Tyndall effect. So the identification process for solutions is more a process of elimination. Do they have particles in the mixture that settle out? No. Okay. Does it show the Tyndall effect? No. No settling, no Tyndall effect means that it would be a solution. So your week 6 assignment, once you have a strong understanding of these terms, solution, colloid, suspension, Tyndall effect, settling out, heterogeneous, homogeneous, I would get your phone, go take a little walk, hike, exploration, drive down to Peters Lake Park. If it's open from COVID-19 restrictions, look in your pantry, look in your refrigerator. You need to find 3 tangible examples of liquids, and then you need to figure out, are they solutions, colloids, or suspensions? There is a liquid mixture scavenger hunt assignment that's posted on the classroom stream for week 6. There's a question inside. When you go to the assignment, you're going to type up your explanation of why your 3 samples are what you picked them to be. You should have 3 note cards. Take your note cards numbered 1, 2, and 3. Whatever you picked as your solution, put the number 1 note card next to it, take a picture of it. And then you're going to explain, how do you know that is a solution? Number 2 is your colloid. So wherever you find a colloid, take the number 2 card, put it in the picture with it, take a picture of the liquid mixture that's your colloid, and then in the question, you're going to explain why number 2 is a colloid, and then do the same number 3 for your suspension. Try to get this assignment done by the end of the day on Thursday so I can look over them on Friday. And then that way, all you'll have to do Friday is your assessment, which will be really short this week. This is an intro week. Last week at AP testing, for those of you guys that are doing that, good luck. If you have any questions, put them in the classroom comments for the liquid mixture scavenger hunt. You guys can help each other out. Also, I'll put a Q&A up, but I don't think you guys are going to need to do too much Q&A this week. 2 assignments, scavenger hunt lab, and the assessment is all you have to do for me this week. We'll jump a little bit more into liquid mixtures next week, a little bit more detailed. Good luck. Stay healthy. Enjoy some of this weather. Hopefully it breaks, and get better every day. So go get that stuff done, get that turned in, and we will wrap up this week. See ya.